This section's on 3.1 complex numbers. So this is a review of what we learned in the last class session. So preferably if you could watch this before today's quiz or the next class session, this hopefully will help you out. Okay, so let's go over example 1. So example 1 that we learned was that if you have a negative square root of a negative 33, you do not want to have a negative inside the radical. So this is the radical symbol right there, also known as square root in this case. And so we want to take the negative out of this radical. So we keep this negative that's outside already. So we have as negative square root of 33. And then we put it as an I. Now the I is on the outside of the square root. If 33 was not a prime number, we would continue on. But since 33 is a prime number, we're done with this problem right there. Okay, let's try example 2. So example 2 is we have two parentheses. We have then it's negative 7 plus 12i in the first parentheses, and then minus parentheses 3 minus 6i. So the purpose of this is to distribute so we could drop parentheses. So in this case, the coefficient that we have right here is an imaginary 1, positive 1. If I distribute the 1 into each parts of this parentheses, it's not going to affect the value of this right here, so I can actually drop the parentheses from here. Okay? But on this negative, if I distribute it to the second part of the parentheses, it will affect our sign, so we will have to do that after we have dropped the parentheses. So let's go ahead and do that. So the negative 7, I'm going to copy that plus 12i, because again, if I distribute the imaginary 1 in front of it, the coefficient, it's not going to affect it. But if I go now the second part, which is the negative times a positive, that's going to give us a negative 3, and a negative times a negative becomes a positive 6i. Okay, so now from here, I drop all my parentheses so I can combine my terms. So I'm going to combine all the real numbers, which is then negative 7 and negative 3, giving me negative 10. And then combine the complex or the imaginary numbers, so that's the 12i and the 6i. So we add those together, should give us then 18i. Okay, and that's your final answer right there. Now let's move on to example 3. So example 3 is similar to example 1. We have a negative inside the square root, so we want to take that out. So if I have the square root of 49i times, now this right here, since they're next to each other, algebraically, this is the same operation as multiplication right here. So it's like a times out here, square root of 9, and then the I out here as well. Okay? In problem number 1, 33 we said was a prime number, so there was nothing we could do with that, so we kept it that way. But in 49, square root of 49 and square root of 9, those are actually perfect numbers, so we can take it out. So square root of 49 is 7, so we have a 7i, i's from here previously, times, and then square root of 9 is 3, so that's 3i. So now we can multiply the two numbers together, so 7 times 3 gives me 21. And then I times I should give us then I squared. Because remember, when you multiply, you add exponents. So it's an exponent of 1 right here, exponent of 1. So 1 plus 1 gives us a 2 right here. Okay? Now there's that little I chart that I gave you last time. So I to the first is just I itself. I to the second is equal to negative 1. So if I to the second is negative 1, that means this right here needs to be substituted with this right here. And so that's going to be the negative 1. So we have then is 21, negative 1. Now it's not negative 1 squared, because that's a mistake a lot of students will make. They'll try to put a square because they think they're substituting the I part. But it's not the I that you're substituting. It's all of this right here, I squared. And we said I squared is equal to negative 1. So that's why you're substituting all of that with negative 1. So your final answer then becomes 21 times negative 1, which is negative 21. Okay? So let's move on to example 4. Now, so example 4 again is similar to example 2, but we're going to do multiplication because there is no operation that separates the two parentheses. So let's go ahead and multiply. So then it's 2 times 2 gives me 4. 2 times the 5i should give me positive 10i, right? Positive because it's positive times positive. Then we go inside. So it's positive times 2, right? Or positive 3i times 2. Should give us positive 6i. And then the last one, the 3i times the 5i should then give us positive 15i squared. Okay, because that's 3 times 5 is 15, and then I times I gives us I squared. So similar to that example 3 that we talked about, because I times I gave us the I squared right there. Okay, so we're going to combine like terms. Most of the time the middles right there, they should be able to combine. So then we have is 4 plus 10 plus 6 is 16, so 16i. And then I just copy my plus 15i squared. Now this right here is similar to what we just did in example 3 right here. We have an I squared right here, and we have an I squared right here. So all of this I squared can be substituted with this right here, which is a negative 1. So then it looks something like this: 4 plus 16i plus 15, and then the I squared, all of that gets substituted as a negative 1. So if that's negative 1, then it's negative 1 times 15 should give us negative 15 then, right? So then we have to bring down these guys right here, plus 4. And so now negative 15 turn into a real number. So then I can continue and combine like terms with the real 4 right here, real number 4. So this should give us that negative 11, right? Plus 16i. And that becomes your final answer right there. Okay? So again, let me just work that one out right there again. So 2 times 2 gives me 4 right there. 2 times 5i should give us 10i. 3i times 2 gives us 6i. 3i times 5i gives us 15i squared. And then from there, combine like terms right there. So that's going to give us 10 plus 6 is 16 right there. And then this drops down, so does the 4. And then we realize that I squared is similar to what we just did in example 2. The I squared turns into a negative 1. All of that can be substituted in there. So we substitute in the I squared with the negative 1 right there. And I drop everything down. And then from here, so then this right here, I have to continue to simplify this. So 5 times negative 15, times negative 1 is negative 15, which then turns into here. So now this became a real number, so now I can combine this with the 4, and that gives me the negative 11. Okay? All right, last example, example 5. So we mentioned last time on the class session that if you have a fraction and you want to get rid of this imaginary right there, it's the conjugate that you have to do. So we're going to multiply the top and bottom by the conjugate. So we mentioned the conjugate is always the opposite sign from the I. Okay? So no matter what we do, please do not change the sign of this. This is not imaginary. Remember, this is the A plus the BI, and so this is the imaginary part. So since this is positive right here, I'm going to put a minus right there. If this was originally a negative, I would put a plus right there. Okay? But make sure the signs are the same top and bottom, because legally up here, if I say it's 5 divided by 5, 5 divided by 5 is 1. So same thing with this one. If I put 2 minus 3i divided by 2 minus 3i, since they're identical, this technically is a 1 right here. So we didn't change the value of this fraction right here. We just basically took this fraction, times it by 1. That's what we're doing. Okay? But the only reason why we're doing this conjugate right here is to get rid of the i's on the denominator. That's what it's going to do. So if you have these two terms, we're going to put in parentheses right there, parentheses, and then we're going to work it out just like how we did on the previous examples. So then this right here, I'm going to take this 5, I'm going to distribute it to here. That's the numerator part of it. So 5 times 2 gives us 10. Then we have 5 times the negative 3i should give us negative 15i, right? Okay, so then the bottom part, we're doing the same thing. This becomes basically like this example right here on example 4. We're going to go ahead and distribute the two parentheses together. So that's what we're going to do. So then 2 times the 2 should give me 4. Then 2, let me just draw that out there. So then 2 times negative 3i should give us then negative 6i. And then this part right here, 3i times 2 should give us positive, right? Positive because it's positive times positive. So positive 6i. And then last one, the 3i times the negative 3i should give us negative 9i squared. Let me extend that little division sign. Okay? So this is what it looks like. Now, this right here should always cancel out because it's positive and negative, so they should cancel out. So if they do not cancel out, then that's when you know you have the wrong conjugate. So you need to go back and check your sign. So again, the conjugate is always the opposite sign on the I part, not on the A part, which is the real. It's on the complex or the imaginary part of it. Okay? So then we're going to go on and simplify this. So let's continue on. So I have then is, again, the numerator is 10 minus 15i. And then the denominator, since all of this cancels out, we have is then 4 minus 9i squared, right? Because then I have to bring this down. So then again, this becomes like example 3. I squared can be substituted. So let's just continue to simplify this. So 10 minus 15i all over 4 minus 9. Oops, let's just put a parentheses now. So negative 1 right there. Okay, because the I squared is negative 1, and then this is still that 9 right there. So then this right here becomes a negative 9. Negative 9 times a negative becomes a positive now, right? So then we have is then 10 minus 15i all over 4 plus 13, right? Because it's negative times negative is positive. Oops, sorry, not 13, 9. So negative times negative should give us positive, so that should give us 9 right there. Okay, now if I add 4 and 9, that becomes 13. So then let's continue. 10 minus 15i all over 13. Now, technically this is correct after this, the fraction part of it, the 10 minus 15i all over 13. But the book will ask us to actually separate it, because later in this chapter we're going to do the quadratic formula and we're going to have to separate the fractions and stuff like that. So let's go ahead and continue on to separate this. So if I separate this, make sure the numerator, or the denominator gets to both of the numerators part over here. So it's going to look something like this, 10 over 13, and then minus, and the only reason it's minus is because of this sign right here. So if this was a positive, then this would be a plus instead. And then this is 15i divided by 13. Because again, 13 needs to be split up evenly to this part right there, and needs to be split up to this part right here as well. So that's how we got this. So this becomes the final answer. So if you compare it to the back of the book, it should give us then this part of the fraction right there. Okay? So those are the 5 examples that we went over in class, and then also will probably be quizzed on. So make sure you go over the video again if you need to.